Okay, class, we're going to start on lesson 6, which is volume. So we have rectangular solids, cubes, cylinders, and spheres. Volume, also called capacity, is the measure of space inside a three-dimensional object. You measure volume in cubic units. In other words, if the size of an object are measured in inches, the volume is the number of cubes, 1 inch per side, you would need to fill the object. Many common three-dimensional objects have at least two identical and parallel faces. Think of a cereal box or a soup can. Both objects have identical faces at the top and bottom of the container. Either of these faces can be called the base of the object. To find the volume of any container with identical bases, multiply the area of one base by the height of the object. So you have the volume is equal to area of the base times the height. Another way to find the volume of an object is to use the formula that applies specifically to that object. Now, I'm going to table the rectangular prism for right now, but the cube, the volume is equal to the edge, or you could say the size to the third power. The cylinder is pi radius squared times the height, and the sphere is 4/3 times pi times radius cubed. Now, the formula for the rectangular prism, I'm going to give you a different formula because I think it's easier, even though it means the same thing. So we will have the volume, and this is for the rectangular prism. It's for the rectangular prism here. The volume is equal to length times width times height. So it's length times width times height. And typically you will see LWH. That's length times width times height. That will be the volume. And as you see here, it just has base times height. So the base is really your length times width. So I'm just putting that out there so you will know what you're multiplying. Okay, now it says here now they tell us we have examples below, but what we're going to do, and this was on page 398. We're going to go to page 399 and start the exercises. So A, it says find the volume of each object to the nearest whole unit. So they want us to round to the nearest whole number. So it says number 1. You notice here this is a rectangular prism. I wrote down the rectangular prism formula we're going to use. So we have number 1, volume is equal to length times width times height. Now our length here is, let's say is 8, our width is 5, and our height is 4. So length, width, height. So the volume is equal to, when we multiply all these together, it equals to 160. So your volume is 160, and they didn't put any units there as far as inches, meters, or anything, so we would just leave it as 160. Okay, number 2. If you notice here, all of these sides are the same. If you go back up here, that is the cube. The cube is this value to the third power. So we're going to take the volume of a cube. So volume is equal to E cubed. The edge is cubed. So the volume is equal to 3 to the third power. The volume is 27. That was problem number 2. Okay, problem number 3. We have the volume of a cylinder. Now, if we go back here, we look here at the volume of the cylinder. The volume is equal to pi times the radius squared times the height. That is the volume of a cylinder. Now, we look here. We know pi, we're around to 3.14. The radius, if you look here at number 3, this is the diameter. Remember, the radius is talking about a circular figure, and this 6 here is the diameter, so we have to take half of that. So the radius would be 3. And then the height would be this 5, even though it's laying on its side. Okay, so now we have volume is equal, well, it'd be approximate because we're using pi here. So we'll take our calculator. I don't know if my calculator is still up. So we'll take the 3.14 times the 3, close the parenthesis. I see I got 33 there. We'll put x squared, and then we would do another parenthesis and 5. And it's 141.3, so it'd be approximately 141. So that would be our volume here, 141. Okay, now we look here. This is also a rectangular prism. So for number 4, we will use the same formula we use for number 1, which is the length times width times height. So number 4, we have volume is equal to length times width times height. So we have our volume is equal to the length is 10, the width is 6, and the height is 7. Even though this has been turned around a little bit. So now we can multiply this out. 10 times 6 is 60, times 7 is 420. So our answer here would be 420 would be our volume. All right, now number 5, you notice that all sides are the same. So we know that we will use it for the cube. So volume is equal to the edge cube. Volume is equal to 1.5 to the third power. And volume, we're going to put an approximation because we're going to have to round to the nearest whole number here. So we could put this in, parenthesis, 1.5, close the parenthesis. We'll press the exponent key here, hit the number 3, and press enter. So it'll be approximately 3. So that'll be our volume for number 5. Okay, now, number 6, you notice we have a cylinder here. So we have the formula for a cylinder. Now remember, we use the formula for the cylinder in problem number 3, which is volume is equal to pi times radius squared times the height. So now the volume is equal to pi is approximately 3.14. Then we had a radius. We actually had a radius listed here, which is 5. And that's squared, and the height is 3. Now we can put this in our calculator, but our volume would be an approximation. So let's pull up our calculator. So we had 3.14. Then we will have 5. Hit the x squared key. Then open parenthesis 3. So we will have, it'll be approximately 236. So now, that took care of problems 1 through 6. Now, we scroll down here. It says choose the one best answer to each question. Question 7 refers to the following drawing. Now, if you look at this drawing, this looks just like a rectangular prism, except for the box is open. So let's take a look here and see if that makes a difference. So it says here a rectangular box with a volume of 80 cubic feet has the length and width shown in the drawing. What is the height in feet of the box? Okay, so they tell us that the volume is 80 cubic feet. Now remember, we're using the same formula as we did for the rectangular prism, which is the volume is equal to length times width times height. Now they told us our volume is 80 cubic feet, so it'd be feet cubed. Now we have this, we're trying to find the height. Now if you look here, we have the length which is 4. The width is 4, but we don't know what the height is. So we had 80 is equal to 4 times 4 is 16h. We're dividing each side by 16. 80 divided by 16 is 5. So 5 feet is your height. So that would be A. So remember, this is 5 feet. Now I didn't write the FT after the 5, but you could write that. Well, let me write it over here. So it'd be 5 feet is equal to the height, which would give us A. So just so that it'd be cleared up, 5 feet is equal to the height, which is A. Okay, now that was number 7. Now we go to problem 8. It says a wooden crate measures 5 feet along each edge. What is the crate's volume in cubic feet? Now remember, a crate is in the shape of a cube. So that means all of the sides are the same. So we would do, for number 8, we'll do the volume is equal to the edge cube. So we have the volume is equal to, they tell us that the edge here is 5 feet. So we'll do 5 feet cubed. Now, of course, you know you can't put feet in your calculator, but you would do 5 cubed, which would give you 125 cubic feet. So your answer here would be C. So it's 125 cubic feet, and the answer is C. All right, now, number 9. It says here that Linda adds a water stabilizer to her children's swimming pool once a week. The instructions tell her to add 1 scoop of the product for every 20 cubic feet of water. About how many scoops should she add per week? So first of all, we need to find the volume of this cylinder. So this is problem number 9. The volume of the cylinder is pi radius squared height. So the volume is equal to pi, which is 3.14. The radius, remember this is the diameter, we'll take half of that. So the radius will be 6 and that's squared, and the height is 3. Now we're going to put this in our calculator. So we will have parenthesis 3.14, close our parenthesis, parenthesis 6. Then we would take it to the second power times parenthesis 3. And that would give us 339.12. So your volume is approximately 339.12. Okay, now it says here about how many scoops should she add per week. So for every 20 cubic feet, now remember this is cubic feet, so it's 339.12 cubic feet. So what we would do now is we would put this in our calculator. We could do the fraction bar. We could do 339.12 down arrow, and we'll type in 20. Because remember, we're trying to find out how many scoops, and every scoop has 20 cubic feet. So that'll be almost 17 scoops. So if you notice here, our answer would be C. So I'll write it out here so you could just say scoops. And then we would do the 339.12 divided by 20, which will give us approximately 17, which is C. So this is our answer, C. And we are done with the first lesson for chapter 6. And now we're going to, the first lesson of lesson 6. And I will upload this to YouTube. So have a wonderful day.